you're already falling. There's no sound, no warning, no sense of speed at all. In free fall, there's nothing to push against you, so your body reads this exactly like floating. Ahead of you, the stars aren't quite where they should be anymore. Gravity is bending their light forward, crowding the whole sky into a shrinking, brightening ring, with a perfect circle of true dark opening at its center. NASA's own plunge simulations render this exact distortion. It isn't artistic license, it's what the light itself is actually doing this close in. That's the only thing that's changed so far, what's rushing toward you in the dark. And depending on which black hole you fell into, you might not be in any danger yet. Most coverage of this moment treats it as one universal rule. That's not quite right, and the real answer is something you can actually calculate. Here's the belief almost every version of this story repeats. Fall into a black hole, and you get spaghettified. Stretched thin by gravity until you're a single thread of matter. Full stop, no exceptions. It's treated as a universal law of the abyss. The one thing every black hole in the universe supposedly does to you the same way. That belief isn't fake, it's just incomplete, and the missing piece is the one variable almost nobody puts back into the sentence. Which black hole? That's not a minor omission either. In this particular story, the mass of the black hole isn't a footnote, it's close to the whole plot. Your actual fate at the edge depends entirely on that one number. And once you calculate it for real, universal is the first thing to break. The force that does the stretching is called tidal force, the same basic effect that pulls our oceans toward the moon, just scaled up until it stops being gentle. It's the difference in gravity's pull between the part of you closest to the black hole and the part farthest away. The physics behind it is simple enough to actually compute. Tidal force scales with mass divided by the cube of distance, and a black hole's event horizon itself scales directly with mass. Put those two facts together at the horizon, and something counterintuitive falls out. The bigger the black hole, the gentler its own edge actually is. I ran that calculation for 3 real black holes, smallest to largest. Start small. A typical stellar mass black hole, the collapsed core of a dead star, around 10 times the sun's mass. At its horizon, the tidal pull between your head and your feet works out to something like 10 million times Earth's gravity over a single meter. For comparison, the gravity holding you in your chair right now is 1 G. 10 million Gs applied unevenly across your body doesn't register as pain or pressure or anything your nervous system even has a category for. The destruction outruns the nerve signal that would tell your brain it's happening. You are not surviving that. You're not even surviving getting close to that. For a black hole this size, real spaghettification happens long before you ever reach the horizon. Now scale up. Not by 10 times, by 400,000 times. Sagittarius A star, the supermassive black hole anchoring the middle of the Milky Way, its mass pinned down by tracking individual stars' orbits around it for decades. Work that won the 2020 Nobel Prize in Physics. 4.3 million times the Sun. Run the identical calculation, same formula, new mass. The tidal pull at Sagittarius A star as horizon drops to less than a 10,000th of a G per meter. Not survivable with effort, but genuinely undetectable. You could cross Sagittarius A star's own horizon, our galaxy's central black hole, and your body would register nothing different at all. Which means the universal rule from the start of this video is already dead. It was never true for black holes in general, It was only ever true for small ones.
Go bigger again.
As big as it currently gets. Ton 618, one of the most massive black holes ever measured. Even the more conservative of two competing mass estimates puts its event horizon over 800 times farther from its center than Earth is from the Sun, more than 20 times past Pluto's own orbit. Run the tidal calculation a third time, and by that same conservative estimate, the pull at its horizon is at least 80 million times gentler than Sagittarius A as already imperceptible pull, and by the larger, more commonly repeated estimate, over 200 million times gentler. On paper, Ton 618 is the single friendliest place in this entire video to cross an event horizon. But here's the part almost no coverage of Ton 618 admits. That headline mass isn't as settled as it's usually presented. The number you'll see repeated almost everywhere, 66 billion solar masses, comes from a 2004 measurement. And here's why a number like that can move at all. Nobody has ever directly weighed Ton 618. Its mass is inferred from how fast gas is swirling in the bright disk around it, using the width of specific light that gas emits as a stand-in for speed. Turning that speed into an actual mass requires assuming the three-dimensional shape of gas nobody can actually see face on. And that one assumption is exactly what a 2019 reanalysis changed, putting the number closer to 41 billion, less than 2/3 of the original figure from the same basic data, just a different modeling choice. That's not a flaw in the science. That's what honest measurement looks like at the actual edge of what we can observe. And whichever number turns out to be right changes nothing about the point being made here. Even the more conservative estimate describes a black hole so large that falling in stops meaning what you think it means. There's one more piece almost never shown from both sides. Everything so far has been described from where you are, falling. But there's a second observer in this story, someone watching you fall from a safe distance. To them, you never actually finish crossing the horizon. Your image slows, reddens, and fades, stretched across their view of time itself until you're indistinguishable from the black hole's edge. To you, falling, none of that slowdown is happening. You cross in what feels like an ordinary, finite amount of time, and keep going. Both descriptions are correct. They're just describing the same event from two positions in a universe where time itself isn't the same everywhere. And that disagreement, not spaghettification, is the actual strangest thing about this moment.
None of this means you'd live forever once you're through.
Crossing Sagittarius A star's horizon painlessly doesn't cancel the tidal force. It only delays it. The exact same physics still applies on the inside, and it only gets more extreme the closer you get to the center. Run that clock forward, and Sagittarius A gives you, from the moment you cross, about half a minute of your own time before that same stretching force finally becomes fatal. Ton 618 buys you far more room, somewhere between about 3 and 5 days, depending on which of the two mass estimates you use, before the same ending arrives. That's not an escape. It's the size of the room you're given before the sentence gets carried out. And even the single most massive black hole ever measured only rents you time. It doesn't offer a way out.
So, back to the start.
You're falling. No sound, no warning. Whether anything is coming for you depends on one number you now know how to calculate yourself: mass. Fall into a small black hole and the universal rule holds. You don't survive contact with the horizon. Fall into a large enough one and you cross without ever feeling it, buying yourself anywhere from about half a minute to several days, only to run straight into a stranger disagreement about time itself, and eventually the same ending everyone gets, just on a timeline the "you'll never feel it" headline never mentions. We don't know everything here. Ton 618's exact mass is still an open question, and what actually happens past any horizon is, by definition, something no signal can ever send back. That's not a gap in this video, that's the honest edge of the science. If real space stories, checked against real data, are your kind of dread, CuriosityStream carries documentaries that go even deeper than this one. Link in the description. That's an affiliate link, and I may earn a commission at no extra cost to you. Subscribe for the next one.